All right, so we're going to do some practice. So the first one that we have is 7x squared times x minus 6. Okay, so part of my job is to teach you efficiency, the fastest way out. So honestly, I could just do a little bit of algebra first and distribute. That'll give me a 7x to the third minus 42x squared. So all I've done is algebra. But now I'm in familiar territory and I can just go term by term. So I'm going to drop that 3 out front and get a 21x squared. I'm going to drop the 2 out front and get an 84x. So now that's done. But the whole point is we're supposed to be practicing product rule and quotient rule. So if I leave it in a product format where I've got a first and a second, then what I'll have is the first, which is a 7x squared, times the derivative of the second. So the derivative of x minus 6 is just 1. And then plus the second, which is x minus 6, times the derivative of the first, which gives me 14x. And then you're done. Well, you notice now if you clean it up, if you get a 14x squared here and a 7x squared here, that gives you 21x squareds. And then 14x's times a negative 6 is a negative 84x. So you get the same answer. It just may not look the same. You may have to do a little bit of organizing first. But you do get an equivalent function. So let's do another one. I have a 3x plus 4 times a 4x minus 5. And again, I'm just going to do product rule because my instructions are find the derivative. So I have the first, which is 3x plus 4, times the derivative of the second. So the derivative of 4x minus 5 is 4. Now, because I'm a lazy math person, I'm going to put the 4 out front. Okay, because this times this has the same value as this times this. It's just more organized this way. Okay, so I've got the first times the derivative of the second plus the second times the derivative of the first. So the derivative of 3x plus 4 is 3. And again, order doesn't matter in multiplication, so I just put the coefficient first, if you would. Okay, so let's do another one. I got an x plus 1. I've got a 9x squared minus 8x. And then plus 3. So I've got a first and I got a second. And I'm supposed to find the derivative. So I've got the first times the derivative of the second. So this thing's derivative is 18x minus 8. So first times derivative of the second plus the second times the derivative of the first. Okay, well the derivative of the first is 1. So we're done. You just leave it like that. Okay, and again, how do you know? What is the purpose? What did you just find? You just found the formula for instantaneous rate of change, or you found the formula for the slope of the tangent line for any point on this curve. Okay, so if I told you, well, what happens if x is 1? You could shove a 1 in here and tell me the slope of the tangent line. Okay, so let's try another one. We've got a 1 plus the square root of t, and then a 4t squared minus 7. Okay, so I want to take this thing's derivative. Well, I need to rewrite first because that's irritating me. Okay, I need to rewrite this radical. So that's actually a 1 plus t to the 1/2. So it's a t to the first power, but I'm taking a square root. And then I have a 4t squared minus 7. So now I can do product rule. So I have the first times the derivative of the second. So this thing's derivative is an 8t. So I'm going to put 8t out front. So first times derivative of the second plus the second times the derivative of the first. And this thing's derivative is 1/2 t to the negative 1/2. Okay, kind of sort of squishy, but he's in there. All right, so let's practice some more. All right, so let's do this one. Actually, let's change the page. We're going to do some quotient rule. So I have 3 over 2x plus 6. And then I have plus a 4x squared. Okay, so what's your bigger picture? Your bigger picture is just addition. Okay, so I can go term by term. But what is this one? This one I'm going to have to do quotient rule. How do you know you have to do quotient rule? Okay, because I've got variables in my denominator. And there's really no clean way yet for us to bring this entire denominator up to the top, because there's still going to be an issue. Okay, so what we're going to do is quotient rule, and you're going to find out that some stuff zeroes out, but that's okay. Okay, so quotient rule says the bottom. So I'm going to write the bottom. Times the derivative of the top. So what's the derivative of 3? It's 0. So that whole thing is gone. Okay, so bottom times the derivative of the top minus, do not forget your minus, the top times the derivative of the bottom, which is 2. And then that's going to be all over the bottom squared. So this thing just turns into a negative 6 over 2x plus 6 squared. And then what's this thing's derivative? He's plus 8x. Okay, he is plus 8x. So you can go term by term, but now we're incorporating some quotient rule in there. So let's try this one. We've got a 1 minus 6t over a 1 plus 9t. So how do I know? My instructions are find the derivative. So I need to use quotient rule because my bigger picture is variables divided by variables. On this one, you could have said the same thing. Okay, because you could have put an x to the 0 here, so it would have been variables divided by variables. Okay, so I've got variables divided by variables. That tells me I'm going to have to use quotient rule. So I've got the bottom. So the bottom is 1 plus 9t times the derivative of the top. So this thing's derivative is a negative 6. Minus the top, which is a 1 minus 6t, times the derivative of the bottom. So the derivative of my denominator is 9, all over the bottom squared. Now, you can clean this up a little bit, okay? I've got WebAssign set up to where it's going to take unsimplified answers as correct, simply because sometimes you don't know what simplified means. Okay, sometimes they want it factored, sometimes they don't. So I just said take it as it is. Later on, we're going to do some higher order derivatives. So it'll benefit you to clean this up. But right now, we're still getting used to it, so let's just do that. All right, so for the next one, I've got a u over a u cubed minus 4. Okay, a u cubed minus 4. So what's my setup? I'm supposed to find the derivative. What I'm looking at is variables divided by variables. So that's going to tell me quotient rule. So now I've got the bottom, which is u to the third minus 4, times the derivative of the top. So the derivative of u is 1. Minus the top, which is u, times the derivative of the bottom, which is going to be a 3u squared. So I can put 3u squared all over the bottom squared. So this thing will clean up to a 3u to the third. But again, you don't even have to do that much. All right, so let's find something more exciting. We have 6x squared plus 5 times x squared minus 1 over x. And I'm going to rewrite this 1 over x as x squared minus x to the negative 1. Okay? So how do I take this thing's derivative? First, so 6x squared plus 5 times the derivative of the second, which is 2x, watch your signs, plus x to the negative 2. So first times derivative of the second plus the second, x squared minus x to the negative 1, times the derivative of the first, which is 12x. And again, what I've been doing so far is I've been writing that 12x out front, but it doesn't matter. It does not matter the order. Okay, so we're going to do a few more. And we have, hang on, I just lost control. Let's do, where are we at? Actually, let me finish up the last few in a different video.